All right, hello everybody. In this video, we'll be going through our quadrilateral properties and the coordinate plane. So this is day 3. And this is really a refresher of our properties from Unit 6. So that's 6A, 6B, and 6C. So a little bit of coordinate geometry proof in this as well. So in our notes for day 3, you'll see a flow diagram, which you guys should seem familiar with. And we're just going to fill out this chart with all the different things that we can think about for each type of quadrilateral. So first is our trapezoid. A trapezoid could look something like this, where at least one pair of opposite sides is parallel. Okay, now I deliberately drew it like that because when you say trapezoid, most people draw their trapezoid like this. But remember, that's an isosceles trapezoid, which has congruent legs and congruent base angles. Okay, so I'm just going to list off some facts off to the side. So obviously it has at least one pair of opposite sides parallel. But again, it has base angles congruent. It has our legs congruent. As far as our opposite base angles, so opposite of each other, those would be supplementary. I'm not going to write that one down. That one's kind of just like a nice little fun fact to know. But then the last one that we use a lot is that the diagonals are congruent. Okay, now at least one pair of opposite sides parallel. What if we had both pairs of opposite sides parallel? That would be a parallelogram. So I'll just draw it like this. Both pairs of opposite sides parallel. And then I'll write that off to the side. Oops, I should say both pairs. Okay, and that's really the definition of a parallelogram. Now, from there, we know a bunch of other stuff. We know that opposite sides are congruent. And again, that's both pairs of opposite sides. We know opposite angles are congruent. We know that consecutive angles are supplementary. And we also know that the diagonals bisect each other. So I'll just add this in here. Diagonals bisect each other. Okay, that's a good list of things that we can talk about, that we know about parallelograms. All right, coming on down to rhombus. A rhombus is a parallelogram which has all the sides congruent. And one of the most used property, I would say personally, is that the diagonals are perpendicular. Okay, it's also true that the diagonals bisect the angles. Okay, now coming over to rectangle. A rectangle is a parallelogram, which obviously opposite sides are congruent, opposite sides are parallel, but then we also have right angles. So it's a parallelogram with 4 right angles. Now if you have a parallelogram with 1 right angle, then they all must be right angles because of the parallelism that's in it. Okay, so I'm just going to add in here, all angles are right. And something else that we use is that the diagonals are congruent. So that's why there's a relationship between a rectangle and an isosceles trapezoid. These are 2 shapes that have diagonals congruent. Now, You put a rhombus and a rectangle together, and that's where you're going to end up getting a square. So we know all the sides are congruent and all the angles are right angles. And then obviously all the parallelogram properties apply up above as well. Okay, so this is all sides congruent, all angles are right angles, and then again, like I said, rectangle plus rhombus equals square. So keep in mind that the square has all the properties of a rhombus. Okay, it also has all the properties of a rectangle. So we can say all squares are rhombuses, but we can't say that all rhombuses are squares. Okay, so everything that's true that a square has is when you go up the flow diagram, and then false going down. So you can't say all parallelograms are rectangles, for example, but you can say all rectangles are parallelograms. Okay, so obviously you guys have study guides that you can look to for theorems. There might be a couple small things I might not talk about, but I really hit upon the big things that we use. So on to the next page. This is where we talk about coordinate geometry and the three formulas you guys need to know how to use. The first is using slope. So slope is our change in y over change in x for any 2 points, x1, y1, and x2, y2. If we have slopes of 2 line segments and they are equal, that means the lines are parallel. If we have slopes that are negative reciprocals, then they're perpendicular. And remember, perpendicular lines create right angles. So that would help us prove a right angle if we were looking to prove something like a rectangle. The distance formula is given down here with our radical. It's based on the Pythagorean theorem. And if we have distances to be equal of 2 line segments, then those segments must be congruent. Lastly, we have our midpoint formula, which I like to think of as the average of the x's and the y's for 2 points given, because you're seeing the x's added up divided by 2 and the y's added up divided by 2. The only time we really use midpoint is when we're looking to prove that segments bisect each other. So if the midpoint of 2 segments is the same, the segments must be bisecting each other, and that's because a segment bisector intersects a segment at its midpoint. So for example, if I gave you some quadrilateral and you found the midpoint of, let's say, AC to be that coordinate, and then you found the midpoint of DB and you found it to be the same coordinate, well, then that must mean that AC and DB are bisecting each other. And therefore, that shape must be a parallelogram. Okay, so I'm just going to run through one example of this. You guys have more in your Unit 6C notes, and just how we do a coordinate geometry proof. So it says, given parallelogram PQRS, so that means I don't need to prove it, with the following coordinates. So P is at -1, 3, Q, R, S. I want to prove that the parallelogram is a square. Okay, now if you're going to prove that it's a square, that means we need to prove that it's a rhombus and a rectangle. Oops, well, let me write there. There we go, a rhombus and a rectangle. So it doesn't matter which one you do first. I think I'm going to do rhombus first. Now, just to make sure we're using all of our different formulas, or at least 2 of the formulas, I'm going to start by using the distance formula. So distance equals, I'm going to write it down, x2 minus x1 squared plus y2 minus y1 squared. Now I'm just going to pick 2 sides. So let's say I pick PQ and QR. I'm going to show that those consecutive sides are congruent, because if I can show consecutive sides in a parallelogram are congruent, then that means that it must be a rhombus. So I'm going to find the distance of PQ. Now P is the coordinate -1, 3. Q is the coordinate 2, 4. And I like to list my coordinates right below it so that I'm not straining my eyes looking up here, because I tend to copy it wrong otherwise. Okay, so it doesn't matter who's x1 or x2 as long as you're being consistent. So I'm going to do -1 minus 2 squared plus 3 minus 4 squared. So that is negative 3 squared plus negative 1 squared. Notice my parentheses. Now, negative 3 squared is a positive 9. Negative 1 squared is a positive 1. So I'm getting the distance of PQ to be the square root of radical 10. Now I'm going to do the same exact thing, but for QR. You'll start to see some numbers repeating, which is good. So I'm getting the square root of radical 10 again, which means that PQ must be congruent to QR. Now, again, this proves a rhombus because if this is a parallelogram, you know opposite sides are congruent, so therefore all those sides must be congruent. Okay, so I'm just going to state that PQ is congruent to QR because the distances are equal. And then I'm going to state a little theorem here. My theorem will be, if a parallelogram has consecutive sides congruent, it's a rhombus, therefore PQRS is a rhombus. Okay, so we're halfway there. So now I have to prove that I have a square. So in order to prove it's a square, I'm going to show that I have a right angle. So I'm actually going to do this off to the side. Kind of box that off here. I'm going to use my slope formula. So slope is y2 minus y1 over x2 minus x1, or change in y over change in x. So let's just use the same two sides. Let's see if I can prove that angle Q is a right angle. So the slope of PQ. Now I'm just going to do rise over run to help me out here. So if I count here, oops, sorry. If I count here, I'm going up 1 over 3, so that's a slope of 1/3. And the slope of QR, squeezing it in here, I'm going down 3 over 1, so that's negative 3 over 1. Now, those are negative reciprocals, which means that my segments must be perpendicular. So here's the first thing that I say. 1/3 and negative 3 over 1 are negative reciprocals. So PQ is perpendicular to QR. Then the second thing I'll say is perpendicular lines create right angles. So angle Q is a right angle. Okay, now that I have those two things, then I can state a little theorem about it being a rectangle. So if a parallelogram has a right angle, it is a rectangle. Therefore, PQRS is a rectangle. Okay? Because I've proved that there's a right angle in it. Almost done. I still have to state it's a square. Now you guys can see that I have separately proven that it's a rhombus and a rectangle. So now I can say my final theorem, a quad that is both a rectangle and a rhombus is a square. Therefore, PQRS is a square. All right. So that covers up that problem. So I did square just because, again, square covers up a good amount of properties to talk through, especially if I gave you that parallelogram first. We could talk about then why I added in a couple things, and that would make it a square. There's other ways to do this. I could have proved it was a rhombus by proving that the diagonals are perpendicular by using slopes. That could have worked. I could have proved it was a rectangle by saying by showing the diagonals to be congruent, as another idea. But this is just one way that I chose to do, just to help show you guys the distance formula as well as the slope formula and take you through some of these things that students tend to struggle with, particularly what you need to write when you're proving a right angle. So talking about the negative reciprocals and the perpendicular lines creating right angles and so on. Okay. Now, obviously, this is one example. You have plenty more in your Unit 6C notes, so check those out. And that concludes our video. So I hope this helped.